Okay, well, hello everybody. I hope week 2 of our now online class um, served you well. Today I'm going to be looking at complex thinking. I decided to kind of condense what we would have done on Monday and Tuesday originally into one class. So when you're done logging in today, you're going to get an assignment. Essentially, that's going to take us through till Friday, and there's not going to be anything new on Leo or anything new expected until Friday. Okay, so that's where we're at with this. Okay, so the first thing I want to think about is when I talk about facilitating complex thinking, what exactly is complex thinking? And so we really want to think about what we mean when we say we want to have our students doing higher order thinking. And so thinking from a psychological perspective, sorry, oh shoot, you don't want to see my Facebook notifications. Thinking from a psychological perspective is the formation of concepts, organizations, and groupings of ideas in the mind. These include being able to form concepts, being able to draw conclusions from evidence, being able to problem solve, and being able to display creativity. So when we talk about complex thinking in the classroom, those are really the skills that we want to talk about. And I say skills very broadly because often I think of skills as like lower level. These are obviously very complex skills. Another thing we want to think about is that what initiates thinking is engagement. And so boredom in the classroom is a significant problem. A Harvard study found that boredom in school progresses as we age. This is really no surprise. There seems to be an increasing emphasis on standardized tests, and we're seeing that being pushed down. So those of you that are early childhood, you need to be aware of this as a potential barrier to having your students engage in complex thinking. The novelty of school itself fades, and then certainly there's a lack of motivation. We move from the tactile and the creative preschool, early childhood, and we move into a more regimented sort of subject-centered learning away from the child-centered learning. So we have to think about that, and we have to think about how to make sure that we're not losing, that we're developing and staying student-centered in ways that allow us to also increase the rigor. So Raymond Nickerson has pointed out, he's a psychologist, has pointed that with or without specialized training, everyone thinks. And so the fact of the matter is, when our students are bored in the classroom, they're thinking. They're just not necessarily thinking about what we want them to think about. They may be thinking about their friends, they may be thinking about their personal life, they may be thinking about a lot of other things. And so, you want to be aware your students are thinking. It's just we want to figure out how to center their thinking and focus their thinking in ways that are effective for our classroom. So, what does that look like? What does effective thinking look like in the classroom? One important aspect is that we want our students to be thinking critically. So we want them to be consciously and purposely directing their thoughts towards a solution or an idea. Contrast that to mindless thinking, which is routine and automatic. Probably these kids, when they're thinking, it's a routine, it's automatic. They do it because they see something that interests them. When we're talking about critical thinking, it's directed, it's purposeful. You're trying to understand something, you're trying to decode something, you're trying to solve a problem. Obviously, we're not going to think fair share, but want you to think about what do you see as an example of mindless activities in the classroom. You probably see a lot of that automatic sort of mindless thinking happening in the classroom. And I want you to think about how we might be able to better pursue our students towards an idea of mindful thinking. Okay? Another aspect of effective thinking is metacognition, which means that our students begin to understand their own cognitive process, recognize their own cognitive process, and sort of think about their own thinking. Teachers need to attend to both developing critical thinking and metacognition to encourage effective thinking. So we need to have our students coming up with problems, critically analyzing, solving problems, but also being able to recognize when there's, like, say, a logical flaw in their thinking, or recognize when their thinking has been limited in some way. Okay, so let's look at some concepts that we have revolving around complex thinking, okay? All thinking begins with concepts. It's the mental abstractions or categories of similar objects, people, or events, or ideas. So concepts are mental abstractions. So we have to think about what does that mean. So when we're developing a web diagram is a great example, a physical example of a concept map of what we're doing in our brains as well, the way that we're networking. But so when we have a concept, we want to think about things like what features are necessary, what features are sufficient, what features are always paired, and then you want to think, so, okay, if we did a concept map for even numbers, what features are necessary? Necessary that it's divisible by 2, every other number, right? What features are sufficient? You can, if you know 2 is the first even number, it's sufficient to know that it's every other number then, right? That's something that you can do. And then what features are always paired? And that again, you can always think about the fact that, okay, I have a even number. If I times it by another even number, I'm going to get an even number. So those are all ways that we begin to develop a concept of, say, even numbers. Okay, but that's a lot harder than it might be. So you might think a feature of a game is it's between 2 people, but there's a game called solitaire. Okay. You might think a feature of a bird is flight, but then there's ostriches and penguins. So there are characteristic features which are typical but not always associated. So we need to help our students to understand that most features that they associate with a concept are actually typical. They're characteristic features, but they're not complete. So we want to help our students define the difference between features and characteristics, okay? We also want to be mindful that our concepts are really rooted in our social mind, meaning that we kind of develop prototypes or representations that are sort of unique to our own experiences, what we witness, what we observe, what we experience ourselves. But not all students are going to have the same prototypes. So typical prototype of a student in Ohio for a bird might be something like a robin or a cardinal. But if you're talking about, say, a student in South Carolina, it might be an egret, right? So we need to be aware of the fact that our mind is developing these concepts, okay? So what we have to start to teach our students is that their concepts can be adapted, they're exemplars. So good teaching begins with the highly typical. So when we teach our students about a dog, they might have a highly typical example of a dog, but then we want to begin to introduce other concepts of a dog so that then they can develop and open up to different ideas about dogs. And dogs is obviously a very simple concept, but it's this idea that we begin with exemplars, but then we develop into larger concepts, okay? So I want you to think about this in your mind. If you were to think about sports, and you'd think about your sports, what were the concepts that you would draw from? So you might, all of us, if we did this in a class, think about how this might be different. Some of us might start with listing sports. Some of us might start with chronology of our experiences in sports. Some of us might start with thinking about skills in sports. Some of us might start thinking about the benefits of sports. And so what we want to think about is we all begin this concept of sports, the shared concept that because we are, grown up in the society that we've grown up in, we have a shared idea of concept of sports, but that concept is unique to us. So when we're teaching concepts, we want to make sure that we're using a lot of examples so that our students are finding themselves in their experiences in our examples. We want to combine examples and definitions. We want to distinguish between defining and characteristic features, and we want to help our students link their new concepts to what they already know so that they see some continuity, so that it's being connected back to their social mind. Okay, so another idea or component of thinking, of good complex thinking, is reasoning, the process of drawing conclusions from evidence. So what does that mean? There's 2 types of reasoning that we want to consider and that we want to make sure, and we want to teach explicitly to our students. There's deductive, which you go from the general to the specific, and then there's inductive, where you go specific to general. So going to deductive, an example of a deductive reasoning is liquids have distinct boiling points. Okay, that's general. Water boils at 212 degrees Fahrenheit. That's specific. So my reasoning here is the liquid that boils at 212 degrees Fahrenheit is water, right? So I draw some logical conclusions. That's deductive reasoning. You'll see that a lot in sciences. You see that a lot in math. In social studies and history and English language arts, you're going to see a lot more inductive reasoning where we're going to go specific to general. So here's an example. This dog has 3 legs. I no longer believe that all dogs have 4 legs. No logical certainty. Conclusions are challenged, and same set of facts may be drawn from more than one conclusion. So this is one of the reasons why when people say that they're a math student or an English student, this is one of the reasons we have to recognize some students are much more comfortable drawing deductive conclusions. They want things to be logical. They want things to be certain. Other students love to kind of look into that realm of inductive reasoning where they're kind of like, almost like, personal hypothesis, and there's no way that you can be proven necessarily totally wrong or totally illogical. And so those are we have to think about those different reasoning skills. So one of the things that we want to do is we want to develop our reasoning skills, kind of break it down into steps. So deductive argument can be broken into what we call a soliloquy. It permits a conclusion from a series of two statements or parentheses. So here's my major premise. All mammals are warm-blooded. Here's my minor premise. All black dogs are mammals. Therefore, all black dogs are warm-blooded, okay? So, but we have to remember that not all linear, you can make logical and invalid conclusions even making linear arguments. So here's an example from House.
Can I have a french fry?
It's your own.
You took the last ones.
What's wrong with you?
I got spinal muscular atrophy.
This is not contagious. Nice bear.
It's a dog.
House. It's not stills. Steroids helped until the patient started bleeding from the ears and mouth.
It's a bear.
His name is Bill. He's a dog.
You win. You can have Vicodin.
Words have set meanings for a reason. If you see an animal like Bill and you try to play fetch, Bill's going to eat you because Bill's a bear.
Are you on something? You got your hands on pain meds.
Bill has fur, 4 legs, and a collar. He's a dog.
It's between cancer and autoimmune.
See, that's what we call a faulty syllogism. Just because you call Bill a dog doesn't mean that he is.
Okay. So what you see there, a little humor, but yes, you can draw logical conclusions that actually have faulty concepts. And the major concepts, those are there's where we have to be careful and draw our students to what they're drawing, the major concept that they're drawing their conclusions from, okay? Another thing that we want to think about is, especially thinking about preparing our students for things like English language arts and history, is the idea of teaching inferences, where you draw conclusions about what you see, but you must be constantly looking for more information to confirm and disconfirm that conclusion. Excuse me, hold on a second. My dog's going after something. Oh, I thought that was a dog. All right, sorry. I thought my dog was going after something, and he wasn't. So you draw conclusions from what you see, but you must be constantly looking for more information to confirm and disconfirm that conclusion. So in that little scene right there, I can draw a conclusion that the doctor isn't a very nice person. And there's a lot of examples of where I can draw that conclusion, the way he talks to the girl. But then I start to say, okay, he's kind of rude to this girl who's at a Christmas party in a hospital. But then I see, okay, he does offer her fries. And so I'm constantly trying to pull my students back to look at the evidence to reconsider the inference they're drawing. So that's something that we have to consider, is how to teach our students inference, but how to get them to draw that inference, to go back to the content, go back to the text, to continue to. The thing about effective inductive reasoning is you're constantly re-guessing yourself. You're constantly sort of weighing your options, okay? So that's something that we want to consider. I'm just going to skip that because it's an activity that we did in class. The other thing we want to think about is being careful for and helping our students to understand when they have faulty reasoning. This is usually what would result from an incorrect application of a heuristic. You saw that in the video. So a heuristic is an informal, intuitive, and often speculative shortcut in thinking. So the girl thinks that dogs are furry and they play fetch, and therefore her animal would, right? Because it is easier to think of starting words for letters, heuristic. Most people would say, so if you go back to this question, what do more words begin with R or have R as the third letter in the English language? This is an experiment that education psychologists did, and most people say, by far, like 80% say there are more letters that begin with R than have R as the third letter, but actually it's the opposite. And that's because it's easier for us, our heuristic, it's easier for us to think about beginning consonants than it is to think about the third. And so when you're given that question, you'd usually go to, because you think about road and relationship and all the R words that you know, right? And red. And so you go through that, you say the beginning R. And what happens is we have a faulty shortcut, a faulty heuristic. It's easier, so therefore it must be right. Okay? Faulty reasoning, then, we need to think about heuristics. A representative heuristic assumes a particular event or object belongs to a certain category by how obviously it represents or resembles that category. But think about this. Why is that wrong when you have a defendant in court? That's a faulty reasoning. Just because somebody looks like a prototype of what looks like a member of a group or an object, it doesn't necessarily mean that they belong in that category. This would be the whole problem with implicit bias or racial profiling, because there's this concept, this idea, this logic faulty representative heuristic. Another thing might be overconfidence. You misrepresent the likelihood of correctness in your judgment, and you're going to have some of your really gifted students are going to be that's going to be a problem with them, particularly when you get to the point where you're challenging them for like maybe one of the very few times in school that they've been challenged like that. They're going to develop an overconfidence, and so you're going to have to help them to see that. Underconfidence is another problem, and very probably more common than overconfidence. This is, many of us probably did that. You ever get the answer right in a test, but then go back and change that answer? Probably what happened is you have this faulty reasoning of underconfidence. Okay? Okay, the next thing that we want to think about is problem solving. And when we are thinking about problem solving, we have to think about ill-structured versus well-structured problems. And ill-structured doesn't necessarily mean wrong. They just challenge our students to think in a different way. When might be best to offer students an ill-structured problem? Okay, so an ill-structured problem, this is a well-structured. You identify the problem, you explore it, you set goals, you create alternatives, you select, you implement, and you evaluate, right? That's a well-structured problem. But there are times when we might put the students into, offer them alternatives, right? And so we're offering them alternatives, and then they have to go back and they have to try to figure out what problem are these alternatives trying to solve, and take it back around through that structure. There are times when it makes a lot of sense for us to offer ill-structured problems for our students. Ill-structured problems allow for insightful thinking. So think about this. Figure out relevant information, selective encoding. So an airplane crashes in the U.S.-Canadian border. In which country are the survivors buried? So that's an example of an ill-structured problem. The students have to go in and figure out what's the relevant information and what's the irrelevant information, and they need to get rid of the irrelevant information, right? And obviously, I hope you all figured it out, that survivors don't get buried. So the most important information is that they call them survivors, which means that they're not buried, right? Selective combination. You want to put together information that is sometimes related in non-obvious ways. So here's an example. I bought a share of stocks in the Surefire Corporation for $70. I sold that share for $80. I bought back the share for $90, but later sold it for $100. How much money did I make? Most people in this situation are going to want to say that they made $10, right? But if you look at it, you can see they made $10 the first time, but or $20, so they made $10 the first time, but they had to pay $10 more, and then they made $10. So really, they did not make $20, they only made $10, okay? So that's an example of an ill-structured problem. Another idea would be selective comparison. You relate new information to old information, seeing the relationship between or among the groups. So if broomsticks are machines, then jet is to pilot as broomstick is to house, hermit, witch, or garden. And so this allows us to take what we know about jets and pilots and what a pilot does with a jet to help us to identify what would make sense in this example. So it would be the witch, okay? So we want to help our students to develop logarithms and useful heuristics. So logarithms establish clear and fixed steps, such as a math equation. Not as fixed are heuristics, but they often a process. For instance, begin by looking for a lost item by going to the last place you saw it. That's a heuristic. So giving people these shortcuts in thinking. Heuristics help people solve problems. One thing is means analysis, where the students can analyze a problem by viewing the goal and then try to decrease the distance between that. Another one would be working forward, where the problem solver begins with an analysis of the current state and then tries to figure out how they got there. Working backwards, where you look at the end and work backwards from there. Scheduling from the due dates might be an example of that. Like if I present my students with a project that's due in May, I might have them work backwards. Okay, you have to turn it in on May 15th. So what are you going to do the week before? What are you going to do 3 weeks before? What are you going to do a month before? Okay. And then another thing would be the trial and error approach to allow them to generate and test their hypothesis and come up with what works. So here's an example of a very common problem that I wanted to show you. So exactly at sunrise, a Buddhist monk set out to climb a tall mountain. The narrow path was not more than a foot or two wide, and it wound around the mountain to a beautiful glittering temple at the mountain peak. The monk climbs the path at the varying rates of speed. He stopped many times along the way to rest and eat the fruit he carried with him. He reached the temple just before sunset. At the temple, he fasted and meditated for several days. Then he began his journey back along the same path, starting at sunrise and walking as before, at variable rates of speed with many stops along the way. However, his average speed going downhill was greater. Will there be a spot along the path that the monk will pass on both trips at exactly the same time of day? Why or why not? And so one of the things that a heuristic would help the students to do would be to see that, yes, there's going to be an intersection at some point. And so helping them to diagram that is really important. So that's a heuristic, because I would have, without drawing this diagram, had said no, there wouldn't be. But this, if you use this diagram, this allows them to see it. Problems have different expressions but are exactly the same. Those are what we call a problem isomorph. This is why as teachers we want to be able to present our students problems in multiple ways. Math teachers represent a problem like maybe verbally, algebraically, and geometrically. Expert teachers represent problems in different and isomorphic ways. Another thing to think about is problem incubation, where you temporarily ease the work activity actively on a problem, and you just give them some time to kind of like think about the problem. Really good teachers are good at kind of creating low stress situations for them to do this, okay? Last thing we want to think about is when we're looking at problems, what can help our students to solve problems? Mental set is something to think about. We have a predisposition to think about a problem in a different way. So students might have a mental set about how to do a book report. And then when you offer them a creative option, that could actually cause them some stress. So you're trying to do something good, trying to give them a new way to approach this, but they have a mental set. This is what you should do in a book report, and that causes some stress. Functional fixedness is another problem with a mental set in which a person is unable to invent a specific new use for something because that they've already used it in the conventional set. So that's why you see things like survival shows, like people doing unique things with everyday objects. They're actually demonstrating that they have been able to move beyond their functional fixedness, and their mental set, which can be helpful, actually is not becoming a detriment to them. Fourth graders so we want some expertise in problem solving. When we know something about the topic, we're going to know something. So here's an example. So fourth graders who were equal in general academic ability but were an expert in soccer were able to learn and remember new terms about soccer much more quickly than their peers. So even though they had everything else the same, all they knew differently was that they were experts. They had a lot more experience than their typical peers in the sport. When they introduced new terms, they were far more likely to be able to remember that new information. So advantages of experts is they perceive large, meaningful patterns of information more readily than novice. In other words, they see the whole picture more easily. They perform their tasks more quickly and with fewer errors. They deal with problems at a deeper level. Their memory for information in their domain is superior, and they take more time to analyze a problem before undertaking it, allowing them to be more efficient. So these are all things. So when the psychologists were trying to figure out why were these fourth graders, what did they do differently than their typical peers, these were the 5 things that they found out that they did differently than their typical peers. So when we can build up our students' expertise in a topic, that's why going deep into, sitting across the pond versus diving into the pond. Diving into the pond is going to set them up for better thinking, okay? Another thing we want to think about is automaticity, which is the ability to execute procedures with very little effort. So here's a little video on this.
Hi everyone. Where in the world did summer go? I have no idea how it's already towards the end of August. But thank you for joining me today. I know many of you are already back in school. So today, let's tackle a question that's going to be really important for those of you teaching beginning readers. What is automaticity? Automaticity is the ability to do something without conscious effort because you've done it so many times. This is going to be really important for your beginning readers because automaticity is what's going to allow them to develop reading fluency and also reading comprehension. So before we talk about automaticity for reading, let me give you an example of automaticity that applies to you as adults. Think about driving your car. How did you get to work today, or how did you get home? If you drove, you might have had one of those days where all of a sudden you pull up to your office or your school and you're like, how did I get here? Oh, I really hope I stopped at that stop sign. You didn't have to think about all the details of driving because you've done it so many times. When it comes to reading, automaticity is quick, effortless word recognition. The students don't have to put conscious effort into decoding and reading the words, which means that they're able to put that effort into other things. After they have automaticity, they can put effort into reading for fluency, and once they have automaticity and fluency, they can put that effort into reading for comprehension.
Okay. So when we think about automaticity, it's just being able to do something automatically and not thinking about it. So if we think about, all of us have just a limited amount of capacity for thinking. And when we think about reading, if too much of that capacity has to be devoted to decoding the word, then it's going to be a lot harder for you to comprehend it, to get to the higher level thinking. Math, that's why you see things like math tables, why science teachers want students to memorize equations, things like that, because automaticity is important. And the other thing we want to think about is transfer. It's not always easy for our students to carry knowledge from one problem over to another. It often means that they have to have some experience changing situations or context. Positive transfer is when a solution to one problem helps you understand another problem. And there's also actually negative transfer when the solution to another problem can actually hurt you because it creates maybe a logical flaw. Positive transfer is extremely difficult for us to find. So we want to think about types of transfer. We want the low road automatic, highly practiced skill that comes automatically, or highly road reflective, where we take an abstract knowledge and apply it to different situations. And we want our students to be able to do both. We want them to be able to use automaticity to be able to read fluently, but we also want them to be reflective. We want them to think about how what they learned about, say, history helps them to better understand something in a novel, okay? So transferring information from one context to another is always our goal, and we have to think about how difficult that can be. How do we help with transfer? We want to make sure we give students lots of examples, and we want to be explicit when we are transferring what they learned to a new situation. For example, math skills transfer more to physics than physics transfers to math. And so we want to be able to help our students to expect transfer and to expect to use their math skills. We also want to demonstrate for them when we're actually applying their physics. Okay? All right. So last thing I want to say to you is you're going to log into Leo and you're going to go to the coursework tab. I also have emailed this to you. You're going to do the complex thinking. In the complex thinking paper, you're going to look at these 3 lessons. There's 3 lessons in here. I want you to watch each of the lessons, and I want you to do an analysis of each lesson. What aspect of complex thinking do you see? You can use your textbook, and you can use this video lecture. But with each one, you're going to identify three aspects of complex thinking that you see in melting ice, 3 aspects that you see in reptile math, 3 aspects that you see in theoretical and experimental probability. So then you're going to pull it together and you're going to answer a question about what do you see the teachers doing in order to plan, what's going on in the planning to help the students to come to this complex thinking. Okay? So this is going to be something that you'll upload to Leo, and on Friday we'll have another short activity for us to do, a last one on complex thinking. All right? Thank you very much, and if you have any questions, you can email me.